Okay, the one type of manometer that I didn't get a chance to talk about in lecture today is what's known as a differential manometer. The idea of the differential manometer is to use it to find the difference in pressure between two locations. And here I'm going to specify my 2 points, 1 and 2, to be right along the bottom edge of this pipe. Now, they're in a horizontal plane, right? So you'd say, well, P1 equals P2. But P1 is not equal to P2 because there's flow along the pipe. So when there's flow in the direction of flow, even if it's in the horizontal plane, we can't assume that the pressure is uniform. So the question is, what is delta P, which I'll define to be, let's say, P2 minus P1. Doesn't really matter which way I set that up. That's the question that we want to analyze here. Now, even though the fluid is moving, the key thing is that in the tube, the fluid is static. There's some motion initially as our manometer deflects, but eventually it becomes a static fluid. So what we have is a fluid in the pipe, gamma, which extends down into each of the ends of this tube, but then in the manometer itself, we have, again, a manometer fluid, gamma m, which is more dense than the surrounding fluid. And it's deflected by an amount h, and then the other dimensions in the problem are L1 and L2. Now I'm going to have to define some intermediate points because we're going to use P over gamma plus Z as a constant. So we're going to define our interface to be point B here and point A here. Alright, so now to basically step through the analysis, what we want to do is define P2 as a function of P1. What we're going to do is go from point 1 to point A to point B, and from point B to point 2. So let's step through that. We have going from 1 to A, we could say P1 on gamma plus Z1 is equal to PA over gamma plus ZA. Or P sub A is equal to P1 plus gamma times L1, where L1 is the difference in elevation. Then we go from A to B. So PA over gamma M plus ZA is equal to PB over gamma M plus ZB, which means that PB is equal to PA now minus gamma M times H. Minus sign represents the fact that we're going up in elevation from A to B. Finally, we go from B to 2, so we have PB over gamma plus ZB is equal to P2 over gamma plus Z2, which means P2 is equal to PB minus gamma L2. Now, the one other thing I need to note here is that L2 plus H is equal to L1. And if you make that substitution and basically take these four equations and substitute for PA into here and then PB into here, the L's actually cancel out. And what we're left with is that P2 minus P1 is equal to simply the difference in the densities, gamma minus gamma M, times H. Now, this is a problem that I would encourage you to wrestle with. Go through each of these steps and sort of track from interface to interface. It's really, in a way, the most general form of using constant piezometric head. Involves multiple interfaces, and in the end we get this very simple relationship for the change in pressure along the two ends of this differential manometer.